This is lesson 2-4, the distributive property. Of all the properties in mathematics, this is probably the most difficult one to first understand. But once you understand it, it's not so bad. Everything here stems upon whether or not you know the vocabulary, so there's some very important vocabulary words we need to talk about here. A term is a number, a variable, or the product of a number and one or more variables. For example, I can have a term that could be x, it could be 3x, it could be 3xy squared. It has to be a number or a variable or the product, which means multiplication of numbers and variables. You cannot have addition and subtraction signs within terms. A constant is a term that has no variables. 6 is a constant. 2 is a constant. Think of it as something that never changes. Numbers won't change. 2 will always be 2. It'll never become -2 or 17 or something weird like that. A coefficient is the numerical factor of a term. So if we go back up to the first example, if I have 3x squared y, my numerical factor of the term happens to be the 3 because it's the number in this term. So out of 3x squared y, 3 is what we consider to be the coefficient. And last but not least, we have like terms. Those are terms with exactly the same variables raised to the same power. For example, 7x and 4x are like terms. They both have x raised to the first power. But 3x and 2xy are not like terms. Okay? These are not like terms because one has an x and one has an xy. In order to be like terms, they have to be the same variable raised to the same power. Now, the distributive property can be used quite interestingly. Let's take a look at the following problem. Let's have this problem. If we decided to do 6 parentheses 1/2 plus 1/3. Most people look at this problem and go, oh, order of operations. I must do what's in the parentheses first, because that's what comes to mind. There's nothing wrong with that. If I did that, I would find a common denominator of my denominators here out of 2 and 3, and that would be 6. And so I would look at this and I'd say, okay, 2 times 3 is 6, so 1 times 3 is 3, 3 times 2 is 6, so 1 times 2 is 2. So I would say that this has to be 3, 6, and this has to be 2, 6. And then I would add them together. 3, 6, and 2, 6 is 5, 6, and I'd multiply it by 6 over 1, and hopefully you'd recognize that these are, you can cross cancel these, and you'd end up with your final answer as being 5. But let's say we look at it slightly differently. Let's say I look at the same problem. I'm going to take 6 times 1/2 plus 1/3. Maybe I want to distribute. Okay, maybe I want to take this 6 and multiply it by the 1/2, and then take this 6 and multiply it by the 1/3. 1/2 of 6 is 3. 1/3 of 6 is 2. And 3 plus 2 is 5. You'll notice we came up with exactly the same answer both times. I find the second method to be a bit easier because I don't have to find a common denominator. This is essentially using the distributive property. You could add the fractions first and then multiply, or you could multiply and then add. That's what the distributive property tells us. Written out, the distributive property is the only property that combines multiplication and division. Excuse me, multiplication and addition or subtraction. It basically says for every real number a, b, and c, I can take a and multiply it by b, c. By doing that, I can distribute this a, and I would get a times b, ab, plus a times c, ac. And it could be written with the a on the other side, and it just becomes ba times ca. Subtraction, same thing. If I multiply a times b, I get ab, and I subtract multiplication of a times c, which is ac. Essentially what it says is you're going to distribute. You're going to make sure that this a goes and gets multiplied by everything inside the parentheses. We distribute it. Kind of like when teachers distribute papers, they give a paper to each and every student. So, some cases you must use the distributive property when simplifying, especially if there are variables. Because if you cannot substitute in for the variable, then you must remove all the grouping symbols to simplify it to simplest form. Let's take a look at number 1 here. We have 3 times 4m minus 7. We're not told what m is. Therefore, to simplify this, we have to distribute this 3 throughout the parentheses. So essentially, we're taking 3 and multiplying it by 4m. And then we're taking 3 and multiplying it by 7. 3 times 4 is 12, and we tack on our m. 3 times 7 is 21. And that's as simplified as that problem can get because we do not know what m is. Problem number 2 has a negative sign on the outside of it, which is the same thing as saying negative 1 times 2x plus 1. Again, we can distribute. We can take this negative 1 and multiply it by the 2x, and then take this negative 1 and multiply it by the 1. So we have negative 1 times 2x plus negative 1 times 1. So this becomes negative 2x minus 1. Notice that by the negative sign being on the outside, it just changes everything inside the parentheses to its opposite. Originally, we had 2x plus 1 inside the parentheses. Now, when you distribute that negative, you have the 2x becomes negative 2x, and the 1 becomes negative 1. So when you have a negative on the outside of a parenthesis, it's basically telling you to make everything inside the parenthesis the opposite. So I have negative 1 times 5 cubed, and then I have negative 1 times negative 6. Because remember, subtraction is adding the opposite, which is probably the best way to write that problem. So now we have negative 5 cubed minus 1 times minus 6 is positive 6. Notice everything was not inside the parenthesis changed to its opposite. 5 cubed became negative 5 cubed, negative 6 became positive 6. Problem 4, again, we're going to distribute. If we take the negative 4 and multiply it by the negative 3a, and the negative 4 multiplied by the negative 6. So negative 4 times negative 3a, and then negative 4 times negative 6, because we want to add the opposite. This becomes positive 12a, because a negative times a negative is a positive. This becomes positive 24, because a negative times a negative is a positive, and that's our final answer. It really is not all that complicated if you're very careful with it. Sometimes we can go so far as to add some fractions. Everybody gets really scared when we talk about the word fractions. Fractions aren't that bad. You just do them the same way you did the regular problem. For example, let's say we have 2/3, and we're going to multiply that by 6h minus 9. So I'm going to distribute my 2/3 throughout this entire parenthesis here. So I'm going to have 2/3 times 6h. And remember, a whole number can be written over 1. And then I'm going to subtract 2/3 times 9 over 1. Or I could do it plus the opposite. It doesn't really matter. Now, if I was looking at this to make it easier, I can say 3 goes into 6 2 times. 2 times 2h is 4h. The denominator went away. Over here, 3 goes into 9 3 times. 3 times 2 is 6, so I end up with 4h minus 6. Again, not all that complicated. The distributive property is not that hard. Now, you can use the distributive property to do mental math. Right? Mental math just is another easier way to do something. For example, let's say I want to multiply 102 times 98. I have 102 and I want to multiply that by 98. Right? I can think of 102 as 100 plus 2 and 98 as 100 minus 2. So if I think of this as 100 plus 2, okay, and I can think of 98 as 100 minus 2, so I could do all kinds of combinations with that. So if I looked at something like, if you think of it 102 and times 98, I could think of it as this, and then I could, and it's not necessarily easier to change them both to something like this. It might be easier for me to think, okay, I'm going to do 98 times 100 plus 2. Now I'm going to do 98 times 100, 98, 100. 98 times 2, well, 98 is slightly less than 100, so we know the answer is going to be 4 less than 200, so it's going to be 196. And when I add these together, I get, excuse me, I just made a mistake here, 9,000 996. I'm done.